Hello, folks. Welcome to Rational Science, directly from Frankfurt, Germany. And today we have a busy day because the other day I failed to answer questions. I left them for today, so they piled up on me. Okay, so I'll be doing that at the end of the lecture today. And so why don't we get started with extinction? Topic which is very interesting for us here and for a lot of people, obviously. Lots of questions. So I'll have it be driven by questions and comments. Okay, here's the first one. Okay, fellow says, referring to me, he says, he used to say that we are the last generation of humans. Now he says, I'm only talking about mechanisms, no dates. No, let's make sure we understand. I never gave a date. I've never given a date saying that, like the 1st of May of the year 2028, we're going to all go extinct. Never gave a date. We're not astrologers, okay? We're scientists, okay? Scientists, what does he do? He explains mechanisms, okay? So, and physics is only about explaining mechanisms, okay? So that's what we do here. What's the theory in general terms? If food disappears, man will die no matter what. Now, a lot of people have trouble understanding that. They don't think that's true, that if we don't have any food, we live forever. I guess we breathe air or something. I don't know. Yeah, if food disappears on the planet, we're all dead. Okay, that's the bottom line on that theory. Where do we get that? We say that's what happened to the animals in the past that died in a mass extinction. Food will disappear when, okay, no one produces it. Okay, so if no one produces food, we all sit, right, and just fold our arms, right? If no one produces food or distributes it for that matter, or whatever is left, for sure, you're going to die of starvation. Okay? So hopefully the only reason you live today is because someone is producing food and someone is delivering it. Okay, I don't know what problem you could have with that, but some people do have problems with that. And then the final part, I guess you could say, is no one will produce food or distribute it, right, when money is no more. Okay, so when money is no more, okay, no one will produce or distribute food. That's in general terms the theory. Now, what part of that you think has to do with astrology? I don't know. It has to do with an explanation of a mechanism. Here we're explaining the mechanism that leads to the demise of our species. That's it. That's all we can say about that. Okay, another fellow raises an issue. I don't know if you've already read it, but I suggest Gary Allen's book, None Dare Call It Conspiracy. Lots of people doing conspiracies these days, especially on the internet, widespread, okay? And all I can tell you is the following as far as Gary Allen's book, okay? The Illuminati will not corral humans in chicken coops or enslave them when money is no more. Why? Because first of all, there won't be any new world order, okay? And there will be the extinction of man instead. Why? Because without money or trade, the filthy rich have no means to compel you to do anything. They can't compel the cops to do anything. They can't compel the military. They cannot compel a single human to do something because they have no way of influencing them because there is no money. There is no trade. Okay? That's the bottom line. That's what the theory says. Whether you believe it or not is a separate matter. Right now we're just talking about mechanisms, okay? Okay, next issue here, next comment says, the question you always have to ask yourself is, who is paying Bill Gates today to tell you to tell YouTube the sky is falling? Is it China, Iran? What's funny is that here we have another fellow, and he says something different. He says, you say that Snowden and Assange are CIA operatives because they are running free. Does that mean you are also a current CIA operative on a mission to reduce the world population? Well, these guys should get together and, figure it out. I mean, One guy says it's China, Iran that's paying me. The other guy is saying it's the CIA, maybe the NSA, or who knows. You know, you guys fight it out amongst yourself. Figure out who's paying me. Okay. Anyways, meanwhile, I can only tell you here that regarding that last comment, the reduced world population, the global population growth rate is coming down without my help. Believe me, I'm not helping it come down. I'm not scaring anyone not to have kids. We're not having kids because everybody has moved to the cities. You can't have children in the cities. That's the bottom line. It's known as density dependent birth rates. Okay. And I've covered that subject lightly in the past. One day I'll probably cover it in more depth. Okay, now regarding misinformation, the CIA disseminates conspiracy theories to undermine conspiracy theorists. Okay, so keep that in mind. It's to the advantage of the intelligence agencies to have lots of conspiracies out there. Why? Because, it confuses people. People say, well, this guy says that JFK was done by Lee Harvey Oswald. The other guy says it was done by the mafia. This other guy says it was the CIA, And so the more theories are out there, what it does is people roll their eyes and say, oh my God, another conspiracy theory. And so it debases all the conspiracy theories. So the only people who benefit from conspiracy theories, from many of them, are the intelligence agencies. They love conspiracy theories. Okay, in fact, they probably throw in some themselves. They disperse some on their own, their own interest. Far-fetched theories are sprinkled to get people to what? To roll their eyes. And you have to choose your conspiracy theories well, okay? Not all conspiracists, okay, believe in the same things, okay? And that's another thing that, helps people in their arguments against conspiracy theories. They say, oh, you're a conspiracist, meaning that you're a flat earther. No, I'm talking about this other thing. No, they put you in the same boat as flat earthers. So everybody who has a conspiracy theory of some kind, they're put in the same boat with everybody else with all the conspiracy theories. And they say, oh, you're a conspiracist. Okay, so you got a label. So what I do, and here you heard it, okay, for the first time, I'm going to give you my conspiracy theories, my list of them, so that you don't misquote me. These are the ones I've researched, and these are the ones I vouch for, okay? Anything that's not on this list is not, you can't blame me for it, okay? So here it goes, just so you know where I come from. These are my favorite conspiracy theories. Secretary of War Edwin Stanton, he was the intellectual author behind Lincoln assassination. Stalwart Roscoe Conklin, he was the intellectual author of the Garfield assassination. The main sinking, U.S. flag. What? To conquer some of the Spanish Empire's colonies out there. Spanish Empire was crumbling, so that's what they did. McKinley assassination, anarchist Leon Czolgosz, he acted alone. He's just, he was a lone gunman, one of the few. Titanic, White Star Line substituted the Olympic to collect insurance. Okay. Roosevelt attempt, John Schrank, again, lone gunman. I don't think there was any conspiracy there at all. They tried to kill him. He carried the bullet for the rest of his life in his chest. Lusitania, Wilson, false flag, his administration. They needed to re-elect him, so he ran with a ticket saying he kept us out of the war, and the first thing he does is get into the war. And the Lusitania was in the back of people's mind. Okay. Florence Kling, she was the intellectual author of the Harding assassination. He didn't die of natural causes. He was murdered. Okay. Pearl Harbor, U.S. flag to false flag to enter World War II. Okay. Not that they said, "Hey, Japs, come over here and attack Pearl Harbor," but they knew Japan was going to attack, and they said, "Go ahead, knock the chip off my shoulder." Okay. And then here's another group of false flags that more more recent, I guess you could say. Hoover, he liquidated Marilyn Monroe. Johnson and Hoover did JFK. Johnson and Hoover did Oswald and a whole bunch of other people, related to JFK assassination. They had to get rid of a lot of people who knew too much. Okay, Gulf of Tonkin, Johnson's false flag. That's essentially known today. Okay, not too many people have doubts about that. Okay, Hoover did Malcolm X as well. In 1968, man did go to the moon. So that conspiracy that the NASA is doing all this work and stuff so that people don't find out about man going to the moon or the space program, nonsense. Man did go to the moon. Man has gone into space. We do send rovers to Mars, and not only the United States, but Russia and China, and other countries, Japan. Okay. Reagan attempt, lone gunman, John Hinckley, no conspiracy there. I think he acted alone. 9/11 Bush team, false flag, quite evident. No, I don't think there's much question in the minds of a rational person that the Bush team did 9/11. Cheney, he liquidated Senator Wilson and his family, got the plane down. Okay, Wilson was from, Minnesota? And flat earthers, possible false flag. I can't tell you for sure. It's kind of strange that these people grew so fast, so quickly in a relatively short time. Possibly just a snowball that just kept collecting people. It could be run by intelligence agencies. And both Assange and Snowden, those are obviously false flags in my opinion. Okay, I have no problem with looking at those two individuals and saying they are USA assets, intelligence assets. Okay, one fellow says, Depression script. Money disappeared during the Depression, so people created local money called Depression script. Okay, so you are wrong. When money disappears, new money appears. No, new money won't appear because trade will be no more, because you only trade, what he's referring to essentially is bartering. Okay, the fact that you use a currency or that you exchange goods or good for service, it doesn't really matter. The point is people won't trade, and in great measure because they won't trust each other once the only thing of value is food. Okay, nobody trades food, whether in the real jungle out there in forests or in the asphalt jungle. Okay. Likewise, when man disappears, a new man will appear. Well, I don't know what kind of man will will appear. What, with antennas or something? No, the economy is not built on faith. It is built on confidence. I like that one. By the way, those are some of the Depression script bills that they used in those days. Why do I laugh at what he said? Because it turns out when you look it up, confidence is a synonym of faith. Faith of confidence. Okay, so it's not built on confidence, it's built on confidence. That's all he said. Okay, the Depression script was used during the Depression era in the 30s, right, as a substitute for government-issued currency. Because the banks closing temporarily and the lack of physical currency, someone had to come up with another form of currency to keep the economy going and a way for trade to continue. Yeah, that's when you have the global economy is still running fine. Okay, so that's what we're missing here, the context. The context is that there's still an economy out there, so you create money because you know you're going to get something in the future. Okay, so that's why you accept that money. Okay. Therefore, the old idea of local currency was reborn. Paper, cardboard, wood, and all other stuff that they use made from fishkin was used as money. Yeah, again, this is not an issue of whether you can create some money and decide to trade with your neighbor. That's not the issue. The issue here is that you won't trade with your neighbor. Okay? But yeah, you can use anything for money. You can even use, trade your wife for his dog if you want. I mean, it doesn't really matter. Trade only as long as trade exists. When trade is no more, then there's no reason to trade. because there's nothing to trade, because you won't get anything out of it, and the only thing of value at that point is food. Food is the only thing of value. And here, let me show you an example, okay? Because people have a hard time understanding that trade disappears. Okay, so here we'll give an extreme example so that you understand why trade is not always in the best interest of the parties. Okay, here it goes. Okay, your ship capsized. Okay, and two fellows, they make it to a little island there on shore. One guy brings a treasure chest. He's got all this money. He says, hey, before the ship sinks, I'm going to make sure I get all the money I can out of there. And he goes and brings in the treasure chest. The other guy brings, food. He brings apples, potatoes, whatever you can find in the kitchen, I guess, right? Or in the stockroom. And it turns out he ends up in the palm tree side of the island. Fine, great. Anyways, the first thing they both do is protect themselves, putting barbed wire and building trenches. Why? Because, one guy's afraid the other guy will steal his stuff, right? But it turns out that one guy has an advantage over the other, and that is that he's got the food, he's got the thing that's going to keep him alive. The other guy's just hoping to go back to civilization and use the treasure chest. Well, it turns out that, it all depends on luck. If another ship comes around, yeah, the guy with the treasure chest might be in very good luck. On the other hand, if no one shows up for a while, that guy's in trouble because he's got a lot of money and he has no use for it on that island. Okay, it's the guy who's got the food that's got an advantage, and he can get the treasure chest once the other guy's dead. Now, I don't know if you understood any of that. Some people have trouble understanding all this stuff. But, yeah, trade is not always in the best interest of the parties and not necessarily always voluntary. So here, let me give you another little story, okay? And this is not mine. It's, some of you might know it. It says Sanjis Backstory One Piece. You can look it up on YouTube. Little video, cartoon video. Just made by the Japanese, and I'll just briefly tell you the story. It's that a pirate and a kid end up on an island, just pretty much like these other two guys. This island's completely empty. There's nothing there, and they managed to get some stuff off the ship. Okay, that sank. Okay, so the pirate gives the kid a small bag of food. Okay, and he says, go to the other side of the island and you look in that direction and find out if there's a ship there coming, and let me know as soon as possible, as soon as you see a ship that's coming to rescue us. And I'm going to do it on this side. And he keeps a big bag, okay? Okay, so the kid goes to the other side and he watches, and he's eating his food, right? Until it finally dwindles to nothing. And he remembers that the old pirate, he kept a big bag. He said, that SOB, he's got all that food, and here I'm starving. And so he goes to where the pirate is, and the pirate says, what, did you see a ship coming? Is that why you came over? He says, no, I came because you gave me a small bag of food, and look at the big bag you have. So he takes his knife and rips the bag open. And it's not food. What comes out is all the gold coins, the balloons. The treasure chest was in his bag. He gave the kid the food, and he kept all the money. Pretty much like I explained a second ago. And, you can look at the moral of the story over there, okay? Anyways, yeah, it's not always a good deal to get treasure, money, bitcoins, Ethereum or whatever. No. Towards the end of when the global economy collapses, the only thing of value will be food. You'd be a fool if you go out there and say, "Oh, I'm going to rob the bank now that the bank's free of people and there's no police. I'm going to rob the bank and take all the money out." Yeah, well, good luck with all that. You won't be able to use it for anything. Yeah, you'll be stuck on that same island. Okay, Another fellow raises another issue, says, what about genetic modification of crops to keep producing food that is resistant to changes in climate and so on? Isn't that kind of science the only thing that can extend the human overall longevity on this planet? This is not about climate change. Believe me, not, at least not the theory we espouse here. This is not about climate change. What is it about? It's about the economy collapsing. And no one's going to be producing genetically modified anything because you got to pay these guys to do that genetically modified stuff. And the issue is that no one will be planting, no one will be harvesting, meaning that no one will be packaging and no one will be distributing food in any way, shape, or form because the economy has collapsed. What I mean by economic collapse, I don't mean a petty 1929 depression or even a recession. I mean a total collapse of the global economy. No trade, no more trade. Money is no more because people will not accept it because they will not be able to do anything with the money they get, whether it's Bitcoin, whether it's fiat money, whatever it is, it doesn't matter. Okay? And bartering, nobody barters food, which is the only thing of value when the economy collapses. You don't trade your car or you don't trade your food for a car. Okay? You let the guy keep the car, you keep the food. When he dies, you take the car for free if there's still any gasoline around. Okay? If anyone manufactures that and distributes it. So no purpose for genetically modified foods. It doesn't help us at all. Okay, just want to mention again related to a subject I touched the other day, which is genetic diversity. Okay, and what do we have? We have the African elephants came out I think yesterday or today. African elephants now listed as critically endangered after dramatic population decline. So the African elephants are disappearing, okay, and partly because of what I explained the other day, the shrinking island theory, that, their world is shrinking. They have less acreage in which to, scrounge around for food. And so, and the reason for that is humans are encroaching on their habitat. Humans are turning a lot of that land into crops, into cropland that is used for food for humans. And the elephants are being cornered. They're being corralled into an island that is shrinking on them day by day. Okay, what does that do? Well, part of the process is the loss of genetic diversity. And here you have a little article. I'm just putting a summary here of what this article says, and there were a couple studies, more than one study. It says Africa has 2 elephant species, genetic analysis confirms. Well, one of those at least it has very little genetic diversity, meaning that the elephants, especially those, I think it's was the Savannah elephant that was declining in genetic diversity or has very low genetic diversity. They've been around for a while, and not only do we have the problem where the world is collapsing on them, their islands are shrinking, but on top of that, they're intermarrying within whatever elephants are out there, and so they have a genetic problem as well, and it's typical. You have a double whammy. You have a genetic loss of genetic diversity, and you have the overturning of the population pyramid, which is an issue related to density dependence. Why? Because their islands are shrinking. So you can't continue expanding and having more and more and more elephants, and their sources of food are declining. And I showed the other day the the bacteria or the fungus on fruits and veggies. At first they grow exponentially, but after their world collapses on themselves under their feet, well, their world starts dropping until they finally become extinct. When there is no more food left, their world collapses totally. Okay, all I can ask is that people who like the issue of extinction, who want to debate or talk about it or put comments or questions, follow Extinction 101 before you do Extinction 102. Extinction 101, mass extinctions of the past, both animals and plants. See if you can answer how animals and plants in the past died, disappeared. If you have a foolproof mechanism, okay. Hopefully you don't have any catastrophic theories, because the problem is you cannot explain selectivity. And then once you have your theory, your foolproof theory, well, then you can say, okay, that's going to happen to man as well, because we cannot avoid that same mechanism. Okay, that's the reasoning behind this. And so, yes, I do have a theory. I'm saying that the animals in the past died when their food sources disappeared, gradually at first and then exponentially towards the end. And they finally went away because their islands collapsed on them. Now, it doesn't mean that all their food completely disappeared, but the forests were getting smaller and smaller and smaller. That means we have a density-dependent issue, means you have the overturning of the population pyramid of different species of animals, in fact, of the whole order. And take, for example, the dinosaurs, the most popular one. And at some point, they disappeared. They disappeared because, you just have intermarriage. You have fewer and fewer of these animals, and their islands are getting smaller. You got the whole whammy all together, including genetic diversity, population pyramid overturn, etc. Yeah. That's the general idea. Why is that important? Well, because that's what's going to happen to man. Okay? What's going to happen, our food sources are going to disappear. Why are they going to disappear? Because we're producing the food for humans. Okay? And we won't produce food for humans anymore because the economy collapsed, the global economy collapsed. A lot of people say, well, I'll produce my own food. People who have land out there, and they say, I'll produce my own food. The big problem there is going to be defense. Okay? You're going to have to defend what you grow out there, and good luck with that when thousands of people from the country come and visit you to share in your bounty. Okay, so the mechanism is the disappearance of food. Okay, that's the mechanism for both past mass extinctions as well as the one that I propose for humans. Okay, let's move on to the lecture of today, and that's got to do with this, I'll call it a thing for now. It's called a tesseract or a hypercube. Okay? And maybe a lot of you have heard about it. Okay, it comes really from relativity. Okay, because it's identified or associated with space-time, which is also a four-dimensional, again, for lack of a better word, I'll say thing, four-dimensional thing called space-time, within which we live. We live within this box known as space-time. Okay, and so yeah, these notions concepts are related. Okay. So let's see, what I'm going to do is I'll drive it through, again, comments that people made, specifically one individual who wrote quite a bit, and I think each point was well taken, in other words, needs to be addressed. Okay? So here it goes. We'll put this man in the spotlight. Okay? Here it goes. Okay, this gentleman says, a sphere is an object. We start with sphere, okay, because we need to find out, what the... how the reasoning goes, okay? It says a sphere is an object we can see and touch. Okay, that's why he thinks it's an object, because you can see it and touch it. And that's what most people out there think an object is, that which you can see and touch. This is the ordinary notion that most people have out there. If you ask anyone on the street, that's probably what they'll tell you. What is an object? Well, it's what I can see and touch. I can see and touch the table, so that's an object. That's the notion people have out there. And in fact, that is the definition we find in the dictionary, the ordinary dictionary. And it turns out it's also a synonym of the word exist, because when you ask someone, well, what do you mean by exist, that this table exists? He said, well, I can see and touch it. So the word exist and the word object or thing, entity, medium, whatever you want to call it, all these synonyms, they're synonyms. Exist and object are synonyms in the minds of all people out there. Okay, and we try to correct that. We have a different definition. Okay? And he says, okay, it is three-dimensional. Okay, true, a sphere is three-dimensional. And he says it can be weighed or measured. Weighed or measured? A sphere is an ideal geometric object. It should be, at least. That's what we think it is. That's what the word sphere has always more or less been alluded to. Okay? And so, you know, when you look at a sphere, you look at something that looks like a ball, you know, something like that, similar to that, but it's a perfectly smooth geometric object. In other words, it's an ideal geometric object because we cannot produce anywhere in the universe a perfect sphere. You know, if you go in there with your, you know, with God's eyes and you look at it with your magnifying glass, you'll see some imperfections. So there is no such thing as a perfect sphere out there in the universe. Therefore, you cannot weigh it, you cannot touch it, and you cannot measure it because there is no such it out there. Okay? So no, a sphere cannot be touched or seen or weighed. But see, we got another issue here, and that's this. Okay, that according to mathematical physics, which is what I discussed last time, a sphere is what is it? It's the twirling of an itinerary. You do an itinerary, which is known as a circle, which is just a bunch of locations. Okay, you cut that itinerary in half, you know, that circular itinerary, you cut it in half and you have what is known as a semicircle. And then what you're going to do, you're going to twirl that semicircle, which is just a bunch of locations, and that's known as a sphere according to all those sources that you see there. And I've discussed that last week, so you can check on that. Okay, so no, a sphere is not an object according to mathematical physics, according to formal geometry. No, a sphere is what you're seeing there, just a twirling of a bunch of locations. In other words, of an itinerary. Okay, in fact, half a circle, which is a circle. What is a circle? A bunch of locations. Okay, now here's the other issue, and that is, can this individual see or touch the sphere that the Klingon has, who lives gazillions of light years away? Can you see or touch that sphere? Hopefully the answer is no, unless you're superhuman, and you know, I do envy your eyesight if you can see it, and I envy your long arm of the law that you can stretch your hand all the way to that sphere and touch it. So if you can't see or touch the Klingon's sphere, is that sphere a physical object? I mean, you know, for him it is, but is it for you? And so we get into this thing where, you know, it comes down to opinions, and you know, it's like it depends on subjectivity. You know, is his sphere an object for you? Does that sphere exist? If exist is defined as see and touch. Okay, so this is the issue, and so this is the question this gentleman has to answer. Okay. Here's another issue in what this gentleman raised. Let me see if I can put this back up here. I can find it. I think it's this one. Yeah. This is a second issue. Okay, here it goes. And it's the word surface that he's got in that second line. He says, its surface is two-dimensional. Well, what I see there is that its surface is three-dimensional. You know, I see that the entire surface, you know, even, but what is a surface? You know, a surface is the ball without its center, okay, without anything in the center. It's just the skin of the ball, so to speak. And that skin is three-dimensional. It's got length, width, and height. So I don't know what he means by that the surface of that sphere is two-dimensional. So that's something he's got to clarify. Now, in science, it's that's a three-dimensional skin or membrane or whatever. And here you look up the word surface. This is out of the Wikipedia. It says the outer face, outside, or exterior boundary of a thing, outermost or uppermost layer or area. The problem is that they use these synonyms known as face and area, And when you look them up, they're just synonyms of the word surface. So we don't know what they said when they said it's the face, the outside area or whatever. And then you have exterior boundary. You look at boundary, it says the farthest limit of an area, border. And if you use the boundary of a three-dimensional object, such as a sphere versus a two-dimensional plane, like a circle, well, those boundaries are not the same. They're not the same notions. Okay? So the word boundary needs to be defined as well a little more precisely so that we know what they mean by surface. And of course, what this shows is that mathematical physics never defined words scientifically. Never. There's not a single definition which is scientific in all of mathematical physics. Okay? And here's another definition of surface. This comes from I think it's the Wikipedia. Yeah, again. And it's got this set of definitions. So let's go quickly through them. It says, surface area of a solid object is a measure of the total area that the surface of the object occupies. Okay, we're talking about volume here? I don't know. Is that what surface area is? The amount of water the rubber ducky displaces? It says this definition of surface area is based on methods of infinitesimal calculus and involves partial derivatives and double integration. What does mathematics have to do with the question before us? We're trying to figure out what a surface area is from physics point of view. We're not trying to calculate anything. We're trying to find out what the definition of surface area is. Specifically, we want to know what a surface is. Okay, so we look up surface, and what is surface? A two-dimensional manifold. What is a manifold? Okay, we looked that up. It's a topological space that locally resembles Euclidean space near each point. Okay, so what is a topological space? What is a set of points? And what is a Euclidean space? Well, it says consists of points. So what is a surface? Well, apparently it's a bunch of points. I mean, that's what all this amounts to. It's just a bunch of points. What is a point according to Euclid? Well, we covered that in the past, and a point is a location. So a surface is a bunch of locations. So why don't we make the effort and define this scientifically? What is a surface in science, in physics? So here it goes, okay? Pay attention. Here's the definition of a surface for the purposes of physics/science. Okay? That's it, folks. It's very simple. We don't need math. We don't need all this gibberish there. 3 or more locations on an object. Okay? If you have 3 locations on a sphere, you have a surface. If you have 3 locations on a plane, ideal plane for example, again you have a surface. Typically in physics, which deals only with objects that exist, a surface is equal to the location of 3 atoms. Okay, so we're talking about the locations of 3 atoms that comprise the object under study. See how simple it was? 3 locations. That's it. That's what a surface is. Okay, now that we have a definition, maybe we can make sense of some things here. Okay, here's this fellow. It says a hypersphere has a 3-dimensional surface, okay, which curves into 4th-dimensional location. 4th-dimensional location. What is a 4th-dimensional location? What the hell is that? I thought location was a concept, and this person is talking about like that location has 4 dimensions. I mean, I don't know exactly what he means. He's got to clarify what a 4th-dimensional location is. As far as I'm concerned, location doesn't have any dimensions whatsoever. You can locate an object using 3 coordinates. That's how it's done in science, okay, in physics. And it says hypersphere is the 4-dimensional analog of a sphere, whatever that might mean. Okay. No. Here's in science. Okay, you have a sphere has length, width, and height, 3-dimensional. Very straightforward. There is no 4th dimension that we're aware of, but people are welcome to propose. First to draw another 90-degree line to those three there to show us that there is a fourth dimension, and give it a name. We need to find out what the name of that dimension is. Okay, and then that's got nothing to do with the location of the sphere somewhere in the universe. Okay, and for that we use these. They're known as coordinates, and they're known as longitude, latitude, and altitude. And they differ from dimensions in that they point towards the object. Okay, so coordinates point towards an object, whereas dimensions point away. It's facing, in what direction the thing in question is facing or pointing to. Okay, so dimensions always point outwards, and coordinates always point inwards. Both are static concepts, and they have nothing to do with numbers whatsoever. That's in physics, okay? We're talking about physics here, okay? We don't talk about math, for example. And what do we do in science? Well, we have to define what the word location means. And here's the definition, okay? We start with the word object. First word we have to define in physics is the word object. You can't do physics without objects. What is an object? That which has shape. Not that which you can touch, not that which you can see. Not all objects can be touched, not all objects can be seen. And we found that out by trying to see the sphere that the Klingon has there. We can't see it. Okay, so no, we can't use that. Space, that which doesn't have shape. Now we know what space is. It's that which doesn't have shape. It's the antonym of the word object. So we have object, that which has shape, space, that which doesn't. Distance is the space between objects. That's what we call distance. That's separation, that gap. Okay, nothingness there, because what is space? That which doesn't have shape. So there is nothing there. Nothing and space are synonyms. Okay. And what is location? Well, it's the set of distances from one object to the rest. Okay. I like to synthesize that in a nice little saying distance is what lies between lengths. Okay. Length and distance are not synonyms in science, in physics. Okay? Length is what an object has, which is continuous matter from one end to the other of an object, and distance is what stands between two objects. They're not even remotely the same concepts. Okay? So distance and length are not synonyms. Not in science. In mathematical physics, they are. And that's why they run into trouble, because they don't understand the difference between length and distance. And the reason for that is that they don't use either one of those concepts. What they use in mathematical physics is distance traveled. Distance traveled. What they do, they unroll the measuring tape because they're interested in measuring. And so they don't have distance or length in mathematical physics. All they have is distance traveled, the amount of units that the tape unrolled. Okay, so if you unroll your tape, and you first have to create a standard, obviously, for example, the meter. And if you unrolled your tape 3 meters, well, that's the distance traveled by the end of your measuring tape. And that's the number that concerns mathematical physics. It doesn't concern physics at all. Physics, we have to define everything qualitatively. Okay? Okay, another comment made by this gentleman. Okay? It's good that he drove the analysis today, the lecture. A circle, so we thank him. A circle, open disk, closed disk, is two-dimensional. Yeah, circle is two-dimensional, no doubt about it. It's a plane. All planes are two-dimensional. Okay, except some of the planes that mathematical physics bends into the third dimension, like Riemann triangles and Lobachevsky triangles, which I covered a couple weeks ago. In all of the above shapes, the only ones that are objects is the cube and the sphere. And I'm wondering why, because he defined it as that which you can touch or see. You can't see an ideal cube, you cannot see an ideal sphere, and that's what the word cube and sphere referred to. They referred to, or allude to, perfect, ideal geometric figures. So neither a cube nor a sphere exists in real life. Again, in real life, everything's made out of atoms, and all atoms are, any structure that you build with atoms is going to be irregular. When you get down deeper, you can get to the atom, like the hydrogen atom, and you can say, was that a perfect sphere? Well, from our point of view, if you were just to look at it and say, well, that's a perfect sphere, because we see it like from a bird's eye perspective. If you were Atom Man and you go there and see it up close, well, our atom is a bunch of threads that weave the surface of the electron, known as the electron shell, the surface of the atom. So even at that level, if you were Atom Man, if you had God's eyes and you were, that close to the atom being a monster and you being smaller than the atom, right? You would see that it's not a perfect sphere either under that condition. So there is no such thing as a perfect sphere in the real world out there. A perfect sphere, a perfect cube, is only in our imagination. And we can only do it through a projection. We cannot have one out here, okay, a perfect sphere out here. Even if you do it with lights, in other words, a hologram, you won't have a perfect sphere. Okay, and so, we can't, so it's just, he says, just because something has shape doesn't mean it's an object. Well, for that, you got to define the word object, and hopefully you will not use the see-touch criteria anymore, okay? Because it's indefensible. And here are very quick reasons why. A couple of them, this is back of the napkin kind of thing. It involves two objects. Whenever you see or touch, you're talking about something that's seeing, something that's touching. The object that you're talking in question, right? The target object. So you need two objects to define object, okay? With see and touch. Second, it's subjective. Did you really see that spirit move the curtain? And yeah, you were on drugs on that day. You were drunk, whatever. You were high. Very subjective. Objects we can't see or touch. There are objects we can't see or touch. Okay, we can't see the air. The air is made out of atoms. Is the air an object? Yes or no? Does it have shape? Yes, of course it has shape. Around our planet, it's a shell. It has shell structure around our planet. But if you want, then you can blow some air into a balloon, okay, and now it has the shape of the inside of the balloon, which is close to a sphere, you could say, if your balloon is spherical, right? So yeah, air can be shaped to anything you want. And the question is, what is the shape of air? No, that's the wrong question. The question is, does air have shape? Anything made of atoms had better have shape. You can put it in any container you want. If you if you put it in a bottle, it has bottle shape. Okay, it has shape. What is the shape? We don't care. Does it change from second to second? We don't care. The point is, it has shape. Okay, we could color code it so that you can see it inside the bottle, inside the balloon, or around the earth, and then you'll know that it does have shape. Seeing and touching are verbs, and you always have to define the word object before you define the word motion, verb, right? Because motion is two or more locations of an object. Okay? So the object has to move, and if it moves, you better have an object to start out with. You can't have motion without an object, which is what mathematical physics has. They get rid of the object and they start using points. And what are the points? Locations. So they move locations. Okay. So what do we do in science? Well, we define the word object. Okay. And why? Because you need what is known as the golden principle of physics, which is you can't do physics without an object. Okay? What would there be to study without an object? What would be happening? What if God wiped out all the objects in the universe except himself, unless he's a spirit or whatever, okay? So he wipes out all the atoms, everything out there, every atom. There's nothing left there. So what is happening? Assuming you're a spirit next to God or God himself, what is he staring at? There's nothing in front of him. He wiped out everything. So what is God staring at if there's nothing in front of his eyes? What is happening? So yes, you need objects to do physics. And we separate that or contrast it with space. Okay, space is that which doesn't have shape. An object is that which has shape. And objects then we can point to. We point to objects, okay, and name them. So we say chair, tree, rock, house, whatever, dog. Concepts we define. Okay, so you have to define what a concept is. Energy is not an object. You have to define the word energy because it's a concept. Okay, and that's why I always say the definition of the word object destroys all religions. And that's why this person is trying to see if he can keep the see-touch criteria, because the definition of object, meaning that which has shape, destroys his religion. He realizes that, so he's desperately trying to go into panic mode, into what is it called? He's trying to fix it, somehow. Because his religion falls there. That's why. Okay. What else do I have here? Yeah, okay. We're going to move towards, again, finding out where we started, where is the Tesseract. Okay, we're moving in that direction. Please have patience. We got to go through this because we got to find out what a surface is, what an object is, these kinds of things we got to take care of first and show what's wrong with the definitions that we currently have for sphere, for, again, for surface, for location, for all these things, these terms, okay? Okay, so where do we start? Well, we start with the word point. Again, we need to know what a point is, and this is what it is for mathematical physics. This is the notion that's out there. This is the notion that they put into what is known as geometry, and what you'll find out that none of what follows now is a geometric figure. That's the bottom line. And so we have the word point. Let me put this up here first. Okay, so I get this, so you can see what they're referring to with all this. Okay. Give me a second here. There he goes. Okay. And so we have context there. We have the mathematicians. What is a line for them? Well, that's a bunch of locations, what they call points, or which they represent pictorially with points, okay, with dots. So do not confuse the dot with a location, which is the real notion of the word point. And here you see it. A point is a primitive notion that models an exact location. What is a primitive notion? It means that it's undefined. They don't want to define it because they can't define it as a location and then put a dot in there, because the dot belongs to physics. It's two-dimensional, and a location is dimensionless and is a concept. So is the point the concept, or is the point the object used to represent it pictorially? That's the question. And it says there, a point is a zero-dimensional mathematical object. Well, I don't know what a mathematical object is. In physics, we only have objects. We don't put any qualifiers in front of the word object. And there is no object that is zero-dimensional. And that ends the word point right there. Okay? The mathematical machinery used to deal with points can be surprisingly slippery. No kidding. Okay? Wolfram mathematics, bastion of mathematical physics, it says a line is a straight one-dimensional figure. Well, I don't know about a one-dimensional figure. There's no such monster in science or in physics or in the real world. So I don't know what they're talking about. I don't know if it's straight, but for sure it's not one-dimensional. There's no such object as one-dimensional. And just in case you said, well, maybe they meant something else, they clarify. It says, having no thickness and extending infinitely in both directions. There is no object that extends infinitely. There is no object that has no thickness. That is one-dimensional. And then it says a line is uniquely determined by 2 points. What was a point? It's a zero-dimensional mathematical object, meaning it's not an object. And so I don't know how they construct a one-dimensional line with zero-dimensional points. And what they're really talking about is locations, and what they're talking about as far as the line is concerned is an itinerary. And there you see the little turtle on the lower right, okay? Just walking along one step at a time, one location at a time. They continue, says the notion of a line is usually left undefined. Oh, a so-called primitive object. Why do they leave it undefined? Why don't they define it so we know what they're talking about? Why don't they say, well, we're talking about location, and this is the definition of the word location? Why don't they do that? Simple. One advantage to this approach is the flexibility it gives to users of the geometry. No kidding. And then they put this notion down there at the bottom. It says all definitions are ultimately circular in nature. Talk about the fine print, okay, these disclaimers. And Wikipedia ends its notion there, its article saying a line may be interpreted as a geodesic. Shortest what? Path. They're talking about a path. They're talking about an itinerary. They're not talking about a line between points. Okay? So yeah, all of geometry in its entirety, so-called geometry, what mathematical physics does, none of it is geometry. None of it has to do with objects. I mean, if they want to do measurement, they want to do calculations and angles and all that stuff, hey, be my guest, knock yourself out. But don't tell me any of what you do has anything to do with physics. Physics deals with the figures. And not one of the names used, like point, line, and so on, used in mathematical physics refers to a figure. It refers only to itineraries, locations, which they call points and lines, which only has the only purpose or the effect is to confuse you. Okay, because people think they're talking about geometric figure, and what they're talking about is itineraries. And that's what all of relativity specifically is founded on. Itineraries. And we're going to get to that in the coming weeks. But just now, I just want you to keep that in the back of your mind, that these people are not talking about geometric figures like when they talk about space-time. What are they talking about? Itineraries. They're talking about motion. They're talking about location. But they use words that sound like geometric figures, points, lines, circles, etc. Tesseract, right? To talk about them when none of those are really geometric figures according to mathematical physics. Okay, so let's start here. Just a quick review. This is what a circle is for the purposes of physics. Okay, I'm sorry, for purposes of mathematical physics. A circle is just a bunch of locations. That's all it is. It's an itinerary. It's known as an orbit. Okay, that's what they're talking about. They're talking about a perfect orbit. There's a center. You got a string, a rope, chain, whatever. The object is at the end of that rope, and you swing it perfectly, conserving the same center all the time. And so the object has all these locations, and that's what they call a circle. All the locations of that ball or cube or whatever you got at the end of your string. So they're talking about locations. They're not talking about a geometric figure. Okay, that's what a circle is for the purposes of mathematical physics. Okay, so what is a semicircle? Once again, here it is. Semicircle is this. It's half a circle. So you swing your ball or whatever you've got, like, in my case here, I got this ball, so I swing it around, okay? That's what a circle is, but the semicircle is just half a swing. And you stop it halfway, okay? Now you take that, and with that, you're going to build a sphere. What is a sphere? Well, you're going to twirl that itinerary, that geodesic around somehow, okay? And here it is, you twirl it around, okay? And that's what a sphere is, just a twirling around of a geodesic. Okay, that's what these people understand by sphere. Okay, so now that we know that it's just a bunch of itineraries and swinging itineraries and so on, let's get down to the tesseract, which is more or less the same thing, but not quite. There is a small difference. See, what they did just now is they moved an itinerary. They moved motion. Let's make sure we understand that, okay? We had something, which they don't identify because they're not concerned with some things. They have all these locations that made up what? The semicircle. Okay, so we have locations. We're not talking about an object. We're not talking about a line, which is what sounds in people's mind. They say, oh, a line, like a little stick. No, no. It's not a curved stick. It's not a straight stick. None of that at all. What it is a bunch of locations. Once they map that, they're going to twirl the locations around, a set of locations. And with that, they're going to build this thing they call the sphere, which is a bunch of locations which are twirling around. That's known as motion, and now they're going to move the motion around. Okay? The tesseract is something even weirder. They're going to move time around. They're going to twirl time around. Okay? And here it is. Okay? So let's go slowly with this so that you understand each point. Tesseract, also known as a hypercube, is a four-dimensional cube. Well, not really, because look at that. This is what this fellow says, okay? And you look at that, no, it's got length, width, and height. It's got 3 dimensions, what I see there, and that's what it's called the tesseract. So I don't know what he's talking about. I mean, maybe his eyesight fails. He can't see the sphere or the cube that the Klingon has, but and I can justify that because he can't see that far, gazillions of miles away. But this, you should be able to see, right there. It's in front of your eyes. It's objective, right? What do you see there? You see 2 nested cubes, you could say, a special type of cube. One that's got these lines connecting the vertices, okay, vortex. But what you see in front of you has length, width, and height. So no, that hypercube is not a 4-dimensional cube. It's a 3-dimensional nested cube. That's what we have in front of us objectively. It's in projection, remember. Really, it's 2-dimensional, the one we're seeing. But we're understanding what they're trying to say here. They're saying, look, you got to look at this as a projection. Okay, it's projection in 3-dimensional, in a 3-dimensional background or platform, okay? And yeah, that's what we have. 3-dimensional cube, double cube you could call it. Okay, so no, the tesseract is not a 4-dimensional anything or a cube or whatever. And it says it is the extension of the idea of a square to a 4-dimensional location. Again, I don't know what that means. Locations are not 4-dimensional. Okay, so locations are dimensionless. Okay, so we have to define the word location so we know what it is. No, location is a concept, and concepts are not made of dimension. They don't have dimensions. Take any concept you want: energy, mass, time. Any concept you want. It has no dimensions. What is it? What does it have? Length, width, and height. Those are the 3 dimensions. So I'm not sure what dimensions location could have. Okay. It says that a cube is the extension of the idea of a square to a 3-dimensional location. Again, locations don't have dimensions. What a tesseract really is, okay, that one there is static, and so you say, well, yeah, I know what that is. That's a 3-dimensional nested cube. But that's not the notion they have for a tesseract. Tesseract is an expanding 3D cube. That's why time is involved. See those vortex there that unite the corners of each one of those cubes, the one on the inside, the one on the outside? That's time. Okay? That's motion in the sense of expansion of that little cube to the big cube. That's what is represented there. Okay? So tesseract is a concept that says a cube is expanding. Okay? That's what the word tesseract stands for expansion of a cube. And I showed this the other day. This is my tesseract so that you understand what we're talking about here, okay? And there it is in graphic mode. You have a cube that is expanding, okay? And what they do with that, they build these 2 nested cubes, which they represent the small one and the big one only. And they represent the intermediate ones with arrows or with lines or whatever. So when you see that cube that's there on the far right side, okay, underneath the red arrow, Well, those are two nested cubes, but those lines that connect the corners of those two cubes, those are to represent that that little cube is expanding. Okay, so it's like a photograph of a movie where they only show the first frame of the movie and the last frame of the movie. But the nonsense doesn't stop there. It continues, and you can see it on the left-hand side of the black region there. You can see the cube is expanding, becomes a hypercube, and a super macho hypercube, okay? So now they're going to take that super macho hypercube, which is a frame that includes the first and the last frame. They're going to superimpose those two cubes. And now they're going to twirl that movie that's synthesized in one frame. They're going to twirl that one around, okay? And that's what when you see a hypercube that's rolling in space, that's the nonsense that these folks are representing. Okay, they're representing two nested cubes, which is really a cube that's expanded. You freeze that image with the inner cube and the outer cube only, not showing the cubes in between, right? And then they're going to twirl that, and what they end up doing is really twirling time, because what unites those corners of those two cubes is those sticks, those lines, they represent time. It's the expansion of the inner cube to fill the outer cube, okay? And here you see it. I've illustrated this so you can see what a tesseract really is, okay? First, we're going to expand the cube. Here it is, okay? So you can see the cube is expanding. Okay, and the little cube becomes the big cube, and they just represent the little cube and the big one. They just take the first and last frame of that, and they say, okay, that's a hypercube. Well, a hypercube is a movie. It's that entire movie synthesized in one frame of another movie. They just take a snapshot of that, superimpose it, do a little collage there, very selective collage. They only take the first frame and the last frame, okay? But again, the nonsense doesn't stop there. Here it goes. Okay, here's what they're going to do. They're going to twirl that thing now. Okay, so now they freeze that image. They're going to twirl time, because remember the lines that unite the inner and outer cube represents the expansion of the little cube all the way to the big cube. And then they're going to twirl this. So they're twirling time. And mathematicians are so used to twirling time that they've lost complete track of what they're doing conceptually. Okay, they don't even know anymore what they're doing, because they're moving time around. And you say, but is time a physical object? Can you move time? Can you move 2 seconds from here to there? And they go through, well, no, let me explain. There's nothing to explain. They're trying to move time, and here they illustrate the motion of time. Okay, so you say, well, what is time? Is time a physical object? And for that, you have to go to the sources, okay? And here's one source. It's from space.com, okay? Space.com, okay? Here we have it, an article that pretty much synthesizes what time is for relativists, for mathematical physics, okay? It says, what is time? Albert Einstein showed that time is an illusion. Oh, that's a good definition. What is time? It's an illusion. Okay, thank you. I always wanted to know what time is. Others say it's what a clock measures, other nonsense that people say out there. They just copy and paste. They don't even know what they're saying. Okay, it is relative. Relative what? It can be it can vary for different observers depending on your speed through space, or maybe through the drug that you took. Okay, I wonder what speed they're talking about here. Okay, what's that got to do with what time is, with the definition of time? Because the article is called What is Time? So finally I wanted to know what a time is. They say, well, it's an illusion. Well, I didn't understand that very well. That's not very illuminating. I didn't understand that. What do you mean by that? Well, it says it depends on how fast you go through space. Well, I still don't have a definition of what we're talking about. What is time? That was the title of the article, okay? To Einstein, time is the fourth dimension. Okay, so it's what? It's an illusion. It's how fast you go through time. It's the fourth dimension. We still don't have a definition. I still don't know what time is, okay? It says space is described as a three-dimensional arena which provides a traveler with coordinates such as length, width, and height. Now those are not coordinates. Those are known as dimensions, not coordinates. Showing location. Yeah, location is determined by coordinates, but again, those are not coordinates. Those are known as dimensions. But people don't understand the difference between dimensions and coordinates. Coordinates refer to location. Dimensions refer to the facing and the pointing of the tilt that an object has with respect to the rest of the universe. And it can only point in three mutually perpendicular dimensions. Okay, that's different than the location of the object with respect to the rest of the matter in the universe, or with respect to three specific points. And again, those coordinates have to be at 90 degrees to each other. Okay, that's why we have names for them. Okay, time provides another coordinate. No, time is not a coordinate. Time is a number line. That's what time is. It's a number line, not a coordinate. Number lines and coordinates have nothing in common. Number lines have magnitude, and what they lack is direction. Time does not have direction, neither does any number line. You can point the number line any direction you want because it doesn't have direction. You can make it upwards, sideways at 45 degrees, doesn't matter. Number lines don't have direction. And second, number lines are not perpendicular to anything because they don't have direction. Okay, and on the other hand, dimensions have those two features. They have direction and they're perpendicular, perpendicularity, orthogonality. They have those two features. Okay, and that's why you can't put a fourth perpendicular dimension because you cannot even imagine such a monster. There's only three possible orthogonal directions in which dimensions can point or face, and you cannot have a fourth perpendicular dimension to that. That's why they never illustrate that. They usually use this space versus time, and they put the three dimensions as the word space in one line, and against them they put time. Like if time had a direction perpendicular to space. What sense does that make? But that's how mathematical physics does it. Okay, and it says time provides another coordinate, although conventional direction, which it doesn't. Although conventionally it only moves forward. Well, which way is your forward? Because my forward is, I think, opposite to your forward. So, if for you time goes forward, for me it goes forward in that direction, for someone else time goes forward in another direction. Forward is not a direction. Forward is a reference in which direction you're pointing. In other words, it's not a direction at all. There is no such direction known as forward. Your forward is opposite my forward. And so time doesn't go forward at all. Forward has to do with, again, if you're using their terminology, forward has to do with space, in which way you're pointing or walking or whatever. And time has nothing to do with direction at all. So what they could mean by time moves forward, I have no idea whatsoever. Okay, so what happens? Because of that, they end up with this. If I can put this up here, put it over here. This is from that article, and they say the following. Say, picture a four-dimensional fabric called space-time. No, I cannot picture that because space is nothing and time is a concept. Nothing is also a concept for that matter. But, I mean, so far we have concepts. We don't have an object, so I cannot picture it, and much less if it's four-dimensional. Whatever four-dimensional is, please draw it, and then we'll know what it is. And hopefully it's four-dimensional. Okay, that means that you have four mutually perpendicular dimensions there. Okay, I know of three. Please show us the fourth one. Okay, that's perpendicular to the other three. When anything that has mass sits on that piece of fabric, it causes a dimple or a bending of space-time. What the hell are they talking about? Bending of two concepts? Well, here it is. Here's what they typically show, and you'll see that for both space-time and the Tesseract here. Okay. Let me put it over here. And so they continue. It says, the bending of space-time causes. They're gonna they're gonna cause something. They're gonna cause objects to move. So they're saying if you bend this concept known as space-time, which they represent with a fishnet, if you bend it just by putting another concept in it called mass, if you bend it, they say that it causes objects to move. So the cause, the reason, or cause really, that the mechanism for why objects move, according to these people, is that space-time causes them, triggers them, pushes them, or pulls them, or whatever, to move. That's what they're saying. They move on a curved path, and that curvature of space is what we know as gravity. Okay, so this is what they teach these folks at the monastery, I guess. Okay, both the general and special relativity theories have been proven with GPS satellite technology. They've proven this. They prove that there's a concept called mass that can bend, warp, okay, whatever, comes in contact with a concept called space-time, which then causes objects to move on a curved path. That's what these people are saying. Okay, and they say that this has been proven. I'm not sure how they can prove it if you cannot even imagine. How can you prove something you cannot even imagine or you cannot illustrate? And they continue saying astronauts are time travelers. What is that? They return to Earth younger than their identical twins that remain on the planet. Oh man, we should travel more often, out there in space so we all become young again, the fountain of youth, I guess. General relativity provides scenarios that could allow travelers to go back in time. Back in time. How do you go back in time? I mean, I don't know how they do this. Maybe a good shot in the arm of some high-level drug. I don't know how you can go back in time. So they say it's according to NASA. The equations, however, might be difficult or to physically achieve. No kidding. Yeah, I doubt that you can go back in time and prove it with a physical experiment. Maybe with equations you can do that. I don't know if you can do that in the lab. Build a time tunnel, a wormhole or whatever. Okay, and the same thing happens here. Okay, and this is known as the hypersphere, and it's the same thing as the hypercube or tesseract, in the sense that what you're seeing is a sphere expanding through time. And there you have a static example and a dynamic example, okay, which they use to show how space-time or the Big Bang expanded, okay. And that's what it is. This fellow says a hypersphere has a three-dimensional surface which curves into a fourth-dimensional location. Again, I don't know what that is. A hypersphere is the four-dimensional analog of a sphere. And yeah, what they're doing is, remember what a sphere was? A sphere was the twirling of what? A bunch of locations. So we have twirling of the locations. Now those twirling of locations, once you freeze that, you make a movie with all those little locations, okay, and they're expanding, they have more distance with respect to the first sphere, first twirling. And, you take only the first and the last one, I guess, for the hypersphere. And I don't know what they're united by, but whatever they're united by, that represents time. So you have an expansion of a sphere, like if you blew a balloon and you take the first and the last images, you kind of make a collage or you superimpose one upon the other, and you say, okay, this is my hypersphere, and then I guess you can play ball with that and you move time around as well. That's what a hypersphere is. That's what these people are talking about. Unbelievable. Okay, so here is follow up on that, which is the icing on the cake, as I call it. One fellow says, the Tesseract concept, blah, 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 blah. I thought the first guy started saying the Tesseract is an object. So is the Tesseract an object or a concept? Which is it? All of the above? here we have relativity treats it like an object. Okay, that's what I say. Mathematicians illustrate this object as two nested cubes. I just showed that, and you can see that if you freeze that image, you have two nested cubes. They put it in motion on top of that. So what they're illustrating is an object, because I can see it's got shape. And that's the definition of an object, that which has shape. And it has shape, whether I see it or not, by the way, okay? But that's one way of, showing that you're saying that you can see it, okay? I can't see the one the Klingon has out there, but I can see this one. Okay, that's why we have to distinguish objects from concepts in physics. We have to know the difference between an object or a concept, because here you have one guy says the Tesseract is a concept, the other guy said no, it's an object. So who's right? Well, the only way we're going to find out is defining the word object and the word concept. That's how we're going to find out. Okay, he who cannot know the difference between an object and a concept is not a physicist. He's a religionist, he's a mathematical physicist, or a spiritualist, or whatever you want to call them. They're not physicists, okay? They're not even scientists. Okay, and so here are my conclusions. Math figures are not figures. Math phys only has itineraries. Line, circle, etc., semicircle, whatever, okay? Bunch of locations, triangles, squares, same, okay? And also, for that matter, spheres, okay? All math solids are hollow. There's not a single mathematical figure, which is that is a physical object. Then even if you put something there, draw something and illustrate it, whatever they illustrate, they say it's hollow. They're only talking about the surface, about the membrane, you could say, that covers a sphere, the membrane that wraps around a cube or a cone or a cylinder. They're not talking about a solid. They're talking about a hollow. Okay? Tesseract, what is it? It's two nested cube if you just look at the image. Okay? Objectively, what you have in front of you is two nested cubes. That's it. But Tesseract, conceptually, what they're trying to really represent there is an expanding cube, which is a concept. Okay? Because now we're talking about, according to the definition of concept, a word that invokes or embodies two objects. Well, here you have two objects essentially, okay, because you take the first and the last frame. It's like if you had two different objects, they're nested, one is superimposed upon the other. That's a concept. So the Tesseract, which you point to, which is two nested cubes, if it's just what's in front of you objectively, that's an object. But the other one, the notion of an expanding little cube that turns into a big cube, that's a concept. So these people have to decide what a tesseract is. Is it the first one or the second one? Okay. And then mathematicians are spinning time when they spin a tesseract, because those sticks that unite the two atoms, those are what? That stick represents time. The time it took for the little cube to become the big one. Okay, let's get to the questions and comments for last week. Really, I have to start with last week because I skipped over them the other day. Okay, here's the first comment or question. They beat me up quite a bit, and it's got to do with observation. And essentially, all these people are saying the same thing. They're saying, look, without observation, you don't have anything to explain. That's what all these people are saying here, okay? So I'm not going to read all of them. You can later on go back if you're interested and see what comments these people made. Essentially, these people are saying you need observation in science, because otherwise, how can you explain something without observing it first? How can you explain a phenomenon, what happened, right, if you haven't seen it first? That's their argument. That's the bottom line. And here's another comment regarding observation. Okay, again, I'm not going to read it because too lengthy, but essentially they're questioning. They're saying, hold it, Bill, are you saying that you can explain something without observing it first? That's essentially their argument. Okay, and again, you can read this later on so that we can move on here. Another comment on observation. There's at least 4 of these that I've got here. Okay, too lengthy to read. Okay, you can read it later. But again, Paul says essentially, maybe this one I'll read because it's a little more specific. It says, if you want to claim that your observation or knowledge of the Earth going around the sun had no hand in formulating your explanation of gravity, right? That your assumption of the Earth and sun's existence, as well as the existence of the ropes, popped out of mere nothingness. You are the dirtiest liar on this entire website. On Earth, not on the website. I'm the biggest liar on Earth. Okay? Yeah, well, I'll get to that in a minute, but I just want to clarify here that existence has nothing to do with observation. There is no provision for the word observation in existence. Things exist even if you're dead. Okay, the moon is going to exist out there when you die. It's going to continue rolling around the Earth. Okay, unless an asteroid hits it or whatever. Okay, so no, observation has nothing to do with existence. Okay, and I didn't observe the rope. Okay, so yeah, it has nothing to do with observation, and I'll get to that in a second. You claim to hypothesize how Mother Nature runs her shop, yet you want to also have all assumptions about nature totally removed from nature. Arbitrary, irrelevant fantasy, no matter how rationally mechanized, is not science. Yeah, for that you got to define science, and science is rational explanations, and so we're concerned about the explanations, not about whether you observed it or not. We don't care about your testimony about whether you observed it or not. And the final comment or question, I guess, here on observation. Again, guy complains that essentially, I'm removing the word observation, and he says, how can you do that? You got to observe before you can explain. So they all say the same thing. And I'm going to answer to all of them in the same way. Okay, so here's my answer to all of them. Okay, all the way down at the bottom here. If I can see it, find it. There it is. Okay, this is the answer to all of them. Here you have the scientific definition of the word science. What is science? Rational explanations. And there you have the scientific method to rationally explain. Okay? You want to explain something to the crowd at a conference, to your friend, whatever. You want to do it scientifically? Well, then you have to follow the scientific method, which you see in front of you. Where do you see the word observation anywhere on that page there? Do you see the word observation? Observer, observed, to observe? No, you don't see observation at all. What is a hypothesis? It's the objects that are going to be mediating the transactions, the phenomena, the definitions, okay? And you have the initial scene or the first frames of the film, or what we call the statement of the facts, not the facts. Facts, only Mother Nature knows what actually happened. And she's got that file hidden away from us. All we can do is present our case. Okay? And people say, well, hold it, Bill. I was there when this guy threw the brick through the window. Yeah, you were there. You saw it. And now you're going to testify. And you're going to tell the world. You're going to tell this Chinese man who's on the other side of the planet. You're going to say, I was there. I saw how the guy threw the brick through the window. Well, he's got to take your word at face value because he wasn't there, and so he's just relying on your testimony. And you say, I filmed it. I got my camera. It was made in Hollywood. You tricked it, so many arguments that we could raise. So, no, or maybe the guy you filmed broke the window first, and then someone put the window back up, and another guy came in with a crowbar, or the dog jumped through the window, and that's how the window broke. That's why I see the glass on the floor now. Your film was, a long time ago, before the window was fixed again. There's so many arguments that you can raise against that. So again, we don't have the exact phenomenon that happened. We don't have the exact thing. Only Mother Nature has it. God, the devil, whoever out there. But they have the real thing in their file cabinet. We can only, we can't say, I observed. Imagine the prosecutor starting his case and saying, I observed the defendant kill his mother-in-law. I observed the defendant rob the bank. Is that how prosecutors begin their cases when they're trying to convince the jury that they testify that they observed? Is that how an explanation is started? Or could it be that the defense attorney and the prosecutor, they have two different versions, sometimes, not always, but many times they have different versions of how things happened? Okay? Maybe the prosecutor says this guy died because he was stabbed to death. And the defense attorney says, no, I ran a test and the guy was poisoned to death, and then the knife was put in his back after he was dead, or while he was still dying from the poison. So what killed him? Well, we don't know. One guy says it was the poison, the other guy said it was the knife. So we don't know. We only have assumptions, and we say, well, let us assume he died with a knife. Here's the weapon, and this is my case. The fingerprints show that this is the guilty party. And the other guy said, well, the poison, that came from that glass, and it has different fingerprints, and I think it came from this other person. So we have two different cases here based on the assumptions, because we don't know exactly what happened. You can say, well, let's run a test. Whatever test you run, it's going to the jury's going to have to rely on belief. No matter what you present, I don't care what you can stand on your head, the jury is going to rely on belief. It's going to be, well, do I believe this guy or do I believe that guy? That's all it's going to be. The jurors always rely on belief. That's why it's only assumptions. You believe the assumption. Really, in the case of science, it's known as you concede the assumption only to understand the theory, okay, not to believe it. And so the jury eventually reaches a verdict, meaning their belief based on the assumptions they give credence to. They say, well, I'm going to go with these assumptions and this theory, and the other guy says, no, I like these assumptions over here and this theory over here. And that's why, sometimes these jurors, they spend days inside the box because they can't reach an agreement on what actually happened, even though, only one thing happened, and here we have two different versions, not only of the theory, but of the assumptions. Okay, another question raised by by one individual here, and he says, those people, referring to the Fermilab mathematicians, a video I made some time ago, says, built nuclear reactor and particle colliders based on that science. What have you actually built? What are your results? Okay, for that we need to know what science is again. What is science? Is science about building reactors and nuclear weapons and all that good stuff? All I can show you is my results. And I think I have better results than these folks. And here it is, okay? For this, we have building technology. Building is equal to technology, not equal to science. What is technology? Technology, inventing, developing gadgets by trial and error. What is science? Rational explanations. So what this fellow thinks is that science has to do with building stuff, with producing physical results, in other words, technology. And that's not what science is. Science is rational explanations, okay? If you don't like that definition, no problem. You can come up with your definition. We'll be glad to tear it to pieces, okay? You got to defend it. You can't say, well, all these people believe that that's what science is. No, that's a statement of authority, of tradition, okay? You got to defend the definition of science on the stage, in the ring with your sword and shield. And then mathematical physics only has irrational explanations. There is not a single rational explanation in all of mathematical physics. Okay? Why? Because they never identify the objects that mediate all these transactions out there. They do physics without objects. They do calculations, they do equations, and then they put in by hand the assumption, which is that everything is mediated by particles. And the particles aren't particles either. They're equations, condensed as particles. And so these are my results. I put the foundations of physics. Okay, let me put this over here to the side. I also, the rope hypothesis, which is the thing I'm proposing, okay, rationally explains how the universe works through images, okay? Why? Because a hypothesis is is a set of objects that you're going to use to explain Mother Nature's or Father Universes or God's or the devil's invisible, intangible world out there. That's what we're trying to explain, how the universe works, how it runs, okay? And for that you need objects, no matter what. You can't say there's nothing there. You can't say gravity is not mediated by an object. You can't say that light is not mediated by an object. You can't say that magnetism is not mediated by an object. And Rope hypothesis identifies the invisible, intangible mediators that underlie the mechanisms of what? Light, gravity, electricity, magnetism, and the workings of the atom. That's what the Rope hypothesis does. So those are the achievement, those are the results. And that's what has something to do with science. What these people did, building colliders, that's not science, that's technology. Why did they build the colliders? What are they colliding? Wave function collapses? Waves? Is that what they're doing? Collapsing waves? Colliding them? Okay, fellow says here, so we see double torus pattern, standing still using ferrocells, okay, or CRT television screens and magnetism. That alone fits the ludicrous definition of object, that which has shape. I'm not sure why it's ludicrous. You just said it's a definition of object, correct. If you can see something there. But the question is, you don't see, he says he sees double torus patterns. A pattern's not an object. Okay? We don't care what the pattern is. We need to identify the physical object. Okay? So patterns don't stand still, okay? Because patterns are concepts. That's why we need to distinguish concepts from objects. Researchers discovered people form a distinct brainwave pattern when they are exposed to a magnetic field that is equal in strength to Earth's magnetic field. But the pattern emerges only when the field points and when the field points and moves in a certain way. This is in the sense of touch. Well, I don't know what is touching anything here. A way more comprehensive definition of object, what we can see and touch that is three-dimensional in a three-dimensional locational environment. I have no idea what a locational environment is, which can be weighed or measured. Yeah, I guess same thing as before. You can't measure a three-dimensional object such as a ball, a sphere, or a cube, because those are ideal and they don't exist. So you can't weigh it. You can't weigh an object that does not exist. Okay? And a sphere is an object that does not exist, and so is a square. Well, square as well, but a cube. Okay? So these are 3D objects that do not exist. They're ideal objects. We can imagine them. We can make an image of them in projection on a two-dimensional platform. We can do all that, but we cannot build it. Okay, so no, you can't weigh, you can't touch it. You can touch the paper, but you can't touch really the square or the cube. Okay, and so the definition of object as see and touch again invokes second object, the person doing the seeing and touching, and so on, which I just covered a minute ago. In both definitions, magnetism is an object. Absolutely not. Magnetism is a concept. It's a phenomenon. Phenomena are not physical objects, but you can draw a phenomenon anytime you want. Okay. I just need the magnetism drawn. I don't need the iron filings or any other things that are indirect. I need the exact image of a magnetic field. You can either draw it yourself or find something on the internet and just point to it with a URL next time. No problem. We'll find out what it is. So here it is. See touch. Okay. Put it over here. These are the problems with the see touch criteria. Can't see touch Klingon's magnetic field 2 gazillions of light years away. Okay, we can't see or touch it. So does that mean his cube or his sphere is not a physical object. Can't see or touch the air. Can't see the air, okay, which is made of atoms. And you can see the atoms that make your table. In other words, you can see the table, which is made of atoms. You can't see the air, which is also made of atoms. So it's because you can't see it, it's not an object, even though both are made of atoms. Okay, so yeah, you got a problem there with your definition. You can't see a circle. I'm sorry, you can see a circle. You can't touch it. You touch the paper, you touch the screen, but you can't see the. You can see the circle, but you can't touch it. Okay, so does that mean that because you can see it? I mean, here you have only half your definition. You can see it, but you can't touch it. The other one you can touch. The air you can touch, you can't see it. What criteria should we use? I mean, it should be an or an and for see and touch. And the see touch criteria is subjective. Okay, did you really see the spirit when you were high? Okay, or drunk? If you didn't see or touch your mama, okay, today, does she stop being an object? I mean, maybe you're in California and she's in New York. You didn't see her, you didn't touch her. Does she become an object only when you can see or touch her? Does she stop being an object as soon as you can't see or touch her? She calls you on the phone and says, "Son, can you see or touch me?" No. That means I'm not an object. That's true. You'll be an object as soon as I can see or touch you again. So what is she? Is she turned into a concept, or I mean, what's going on here? Spirit? Does she cease to exist, which is another, see, touch criteria for exist as well. So I put down there, the only purpose of the see, touch criteria of ordinary speech is to stealthily introduce technology into science. Because what are we going to do in the lab? We're going to run an experiment. For what? To develop technology. Is that science? No. Science is explaining mechanisms as it relates to physics. Okay? It's explaining mechanisms. We need to know how this universe works, then we're done with science. Once we figure out how this universe, there is no more physics. One branch of science. What continues is philosophy, which is explaining purposes and reasons, why someone did something. Okay, and again, just in case, rub it in. Okay, here's the Klingon. Can you see or touch his cube, or his sphere? The answer is, I think no. He's 1 gazillion light years away. Unless you have superhuman eyesight, then no, you can't see any of that. And does that render his sphere and his cube as non-objects? No, those are objects. They are objects that do not exist. They don't have location. Okay, couple more issues here. First one, fellow said, I think it's the same guy. He says, when we use vortex coils, we are putting magnets into motion with what? Frequencies. It's just that simple. Well, I don't know what, I don't want to put words in his mouth, but I drew this freak that he's talking about, and he's pushing a magnet. Is that what he's referring to when he says this freaky frequency, whatever? I mean, what does a frequency look like? He says that the frequency is causing the magnet to move. Now, I can imagine a dog pushing a magnet with his nose. I can kick it with my toe. There's so many ways to move an object, but the only way I can move an object is by having it come in contact with another object. Otherwise, you're introducing spirits. And this guy says he does it with something he calls frequency, a freaky frequency. Okay, and yeah, if the freak is what's pushing a magnet, I drew that one there. But I mean, if he's got I don't want to put words in his mouth. If he's got another freak out there that pushes magnets, he should draw it. He should show us what he's talking about when he says that a freak pushes magnets. Okay, one fellow says, I like this one. He says, boring us to death with your 2-hour monotones. There's a quick solution, and I just don't know why you didn't think about it. You just can tune off after the first 2 minutes if you want. I mean, didn't you think about that? Why did you wait 2 hours? How did you know it was 2 hours? Did you just look at the time on the video? And final issue, the fellow says, Bill, why don't you make a video about Satanism? Well, yeah, I am Satan. Okay? I didn't put my 3 6s there in my forehead. Okay? I'm also God. Okay? When I dress up as God, I remove the 3 6s. Like now, I'm God right now. Okay? I am the author of a book called the Bible. And I hope you read it for your own sake. I mean, when you get up there to the pearly gates, I'll be talking to you, okay? And so what I wrote in the Bible, and I want you to see that here's proof that I'm both God and the devil, whenever it suits my fancy, okay? And again, the anger of the Lord, me, yours truly, okay, was kindled against Israel, and moi, moved David against them to say, go number Israel and Judah. And you'll find that in book 2 of Samuel, right? And it's at 24:1. Okay? And then in another book, Chronicles 1, 21:1, I say something similar. I hope you caught this. I hope you all read this. If not, read it today. Okay? And Satan, yours truly, moi, okay, stood up against Israel and provoked David to number Israel. So I put proof in the book that I'm both God and the devil. Now you can call me Jehovah if you want. You can call me Satan, Lucifer, or you can just call me Bill. And I'll see you on Sunday. I'll see you then. Bye-bye.